Boom, boom, and welcome back to math today. It is beautiful out there. We're going to look at x-intercepts with a multiplicity of 2 today. And that just means that this factor or this multiplicity of 2 means that the factor occurs twice. So we'll start by factors that are occurring once, and we're going to move it over to occurring twice just so we can see the difference. So I'll just make up a couple factors. We have x minus 2 and we have x plus 4. And you can see that in that equation, those factors are only occurring one time. And as you look at that, you can see that the formation and the way in which the curve, or the parabola in this case, crosses that x-axis, nothing significant is happening there. It just looks like we have one individual intercept. But now I'm going to switch it out a little bit. I'm going to say, instead of having one x minus 2, I'm going to write 2 x minus 2's in there. And check out what happens. As soon as I do that, this root over here on the left-hand side changes. I mean, on the right-hand side changes significantly. Look at that. It becomes parabolic in nature. Okay? And because it starts taking that form of the parabola, you can tell that is actually happening 2 times. And you can see it right there on the x-intercept. We can go ahead and we can even change the other one. Check it out. What happens if we have x plus 4? Okay. Notice that in this case, I say, well, x plus 4, okay, gives us another parabolic form right there, x plus 4, and it gives us another parabola right there. And we can continue to do that. And of course, to make life easier, we can actually just say, well, let's, instead of writing x minus 2, we can write x minus 2 squared and x plus 4 squared. And notice what happens. It gives us the exact same graph. So I have a problem. Of course, I'm going to have a problem for us to work through. Now that we've identified that, let's go to this equation, and we are going to cover it up, making the equation that covers that up. So let's go ahead and take a peek at that real quick. So the first thing we are going to do is we're going to identify the x-intercepts that we have. In this case, the first x-intercept, just looking at it as -5, x equals -5. And the second intercept over here is x equals to +2. And what I want to do is identify the factors. And I say, okay, well, this factor must be x minus 2, but it has a multiplicity of 2. And I know that because that multiplicity is making that parabolic form. Now I come over to this one, I say this must be x plus 5, but notice this only has a multiplicity of 1. Because it's going straight through, nothing significant is happening there. Once we get that, we can actually start building the equation fairly easily, okay? Let's, I'm going to clear out the drawing and let's start doing the math real quick. So I've got x minus 2 has a multiplicity squared. And then I have x plus 5 that has a single multiplicity, so it just has the first power. And if you remember, one of the things we did was we pick a point along that curve. So I'm going to pick our y-intercept right here. It looks like the y-intercept is 0, 5. Okay. And I'm going to plug in the y-intercept of 0, 5. Okay, so let's do that. 5 goes in here. And then, of course, remember, wherever there's a x, we're going to put in 0. So 0 minus 2 squared, 0 plus 5. Okay, I'm going to have 5 equals to a. 0 minus 2 squared becomes 4 times 5. Or 5 equals to a times 20. And then we're just divide out by 20. That gives us a equals to 1/4. And I can finally rewrite my equation because we need to take that function, make it look nice and pretty. Let's call it f of x. And I'm going to write 1/4 x minus 2 squared x plus 5. Let's just verify this just to make sure. It's always good to do that. So I'm going to go ahead and write 1/4 x minus 2 squared, and then x plus 5. Let's verify what we have, and boom, it's looking good. Ought to be in Hollywood. We got this right.